This is my third movie discussing differences between the Galerkin finite element method versus the finite difference method. The first thing I'll point out that I didn't write down here is that the finite difference method approximates derivatives with difference equations to solve for differential equations. But the Galerkin method is really a class of methods for converting continuous operator problems to discrete problems. And the aim of the Galerkin method is to produce a linear system of equations to represent a differential equation for solving. So some of the steps involved with a finite difference method approach is the finite difference method approach creates a mesh of points, whereas for Galerkin we're really considering a mesh of nodes. For the finite difference method we would introduce derivative functions, like the second derivative function, and we would take the forward term, the current term, and the backwards term over delta x squared. For the second derivative, first derivative, we have our forward term and our current term over delta x. And we would substitute in these equations into our differential equation, and then we would work through the substitution and obtain an equation for each point in the mesh. And then once we have our number of equations and unknowns, which if we have a 4-point system or a 4-point mesh, we'll have 4 equations, 4 unknowns. And we solve for the equations and unknowns to get our solution. But the Galerkin method, as I said, we create a mesh of nodes, not points. The Galerkin method uses a system of weighted basis functions, and it uses Lagrange polynomial approximations for all nodes in the mesh, and these are linear approximations for local basis functions. And using the local basis functions, we find global basis functions, and we use those to find our equations and unknowns for each point. And then we solve these equations, and we can put these typically in matrix form. We have a K matrix or stiffness matrix, and the U matrix, which is our approximate solution, and F is our forcing vector. And those are the differences between solving with a Galerkin FEM method versus a finite difference method.